Hello everyone, this is Tiger again. So today we will talk about the 2018 JMC paper, and this is going to be the first half of it, alright? So this half of the paper is kind of moderate, so I would say that it is not too easy, not too hard, and I believe that all of you have performed fairly well in this half. So let's take a look at what questions we have, alright? So the first one, definitely this one is easy. So just a simple numbers and operations question. And we can see that it's about bitmas, right? So what is the value of 222 adding 22 in brackets divided by 2? We know that in bitmas, of course, I'm going to calculate what's inside the brackets first, which we have 244, and then I am dividing it by 2. So I have 244 divided by 2, which is going to be 122. I guess you're not making this calculation wrong, are you? Or of course, if you want to apply the, divisor, if you want to apply the distributive rule to it, so you can first try to do 222 divided by 2, that is 111. Then you add 22 divided by 2, that's 11. So you get 122. But that's going to be no easier than this. So why not just do the operations as it's supposed to be, right? So that's the first question. And let's take a look at the second one we have. So the second one is a simple word problem. So I would say that it's just about the basic addition and subtraction, which I don't really want to put it into any category. So it says that a train carriage has 80 seats, and all the seats were already taken where 7 people were standing, which means that there are now 80 plus 7, which is 87 people in the carriage. And it says that at Banbury, 9 people left the carriage, which means that there will be 9 less. 28 people entered it. So we are adding 28. And now that's the total number of people there. And it says that all the seats were taken, and it's asking you how many people now had no seat, which means that I just need to take away the number of seats there. And you can see that 80 and minus 80 are going to effectively cancel out each other. If you are just writing this down following the question, you will be able to solve it. So we have 7 take away 9 adding 28, which is 7 adding 28 take away 9, right? So we have 35 take away 9, and that's going to be 26. All right, so the answer is D, 26. As for the third question, so this is a geometry problem on angles. And to be more specific, it's about the angles of regular shapes. Or you can also say that it's about interior angles. But I would just prefer to put it like angles, all right? So we know that for a square, all the angles are 90 degrees. And for an equilateral triangle, all the angles are 60 degrees, right? And we also know that a diagonal of a square is going to cut the right angle into halves, which means that each half is going to be 90 divided by 2, which is 45 degrees. So now we can see that X is formed by a 45-degree angle together with a 60-degree angle. So that's going to be 45 adding 60, which is 105. All right, so that's the value of X, 105. And the fourth question, so this is another calculation question basically, but it will require you to know the shapes in geometry. So I would say that it's about shapes. Now, first of all, we should know that a decagon is 10-sided. Hopefully you still remember that. And an octagon is 8-sided. Oh, so it has 8 sides, all right? And it says that the perimeter of a decagon is 8 times the perimeter of an octagon. So what is the perimeter of the octagon? Say the perimeter of Q. That's going to be 8 times 10 because the side length is 10 and it has 8 sides, right? So it is 80 centimeters. And as for the perimeter of P, it's going to be 8 times the perimeter of Q, which is 80. And that's going to be 640 centimeters. And as for the side length of the decagon P, let's say side length of P, is grammatically more correct. It's going to be the perimeter divided by the number of sides it has, which is 10. So the answer is going to be 64 centimeters, which is going to be E. All right, that's for question 4. Well, so far it's still pretty easy. Let's move on to question 5. So question 5 is just a word problem involving time calculation. So I would say that it's a word problem with time. Okay, so it left at 6:15, arrived at 8:48. So we just need to do 8:48 subtracting 6:15 to see that it's going to be 2 hours and 33 minutes, which is equal to 2 times 60, that's 120 minutes, adding 33 minutes, which is 153 minutes. All right, so that's going to be the answer, 153. As for the 6th question, so this is a pretty clever one. It might spend you some time if you don't know magic squares really well. So it belongs to miscellany and it's going to be about magic squares, right? So essentially we know that in magic squares all the rows, columns and both main diagonals have the same total, which means that if you look at these this diagonal and this column, they should have the same total, right? And I want to find the value of x adding y. So now, let's say this is called box Z. 6 adding 7 adding z is going to be equal to x adding y adding z. That's what we call a V model in magic squares, all right? And that's both equal to the line sum, which means that you can just cancel out the z in the equations. You can see that 6 adding 7 is x adding y. So x adding y is 6 adding 7, which is 13. So the answer is going to be D, that is 13. All right, as simple as that. It's going to save you some time if you know these kinds of magic square models well enough. And for question number 7, it's about numbers and operations. And I would say that it is actually about arithmetic progressions, believe it or not. Because what we are using in this question is how to find the number of terms in an arithmetic progression. As you can see it, I want to know how many integers are there between 20 adding 18 and 20 times 18 exclusively, right? So once I know the smallest number and the largest number, I will be able to find the number of terms between them, because the integers are actually also an arithmetic sequence with a common difference of 1. So the smallest number, the minimum term, is equal to 1 more than 20 adding 18, right? So that's 39. And the maximum term is equal to 20 times 18 and 1 less than that. So it's going to be 359. And as for the number of terms, starting from 39, ending at 359, that's going to be the last term, take away the first term, divided by the common difference, which is 1, so we don't need to do anything there, and then adding 1. So that's going to be 321 as the answer. Okay, so B is going to be the answer for this question. Well, just make sure you know how to calculate the number of terms for an arithmetic progression. That is sometimes pretty useful. And as for question 8, I would say that it is going to be a word problem on fractions. It says that Jill scored a goal halfway through the second quarter of a netball match. So what fraction of the whole match remained to be played? So we know that the whole match can be represented by a fractional 1, which represents 1 whole, right? And the first quarter is already gone, which means that I just need to take away the first quarter, and then half of the second quarter is gone. So we need to take away half of the second quarter, which is half of a quarter, of course. And that's going to be equal to 1 take away a quarter, take away an eighth, and we can just do the common denominator 8 for them, which is 8 take away 2, take away 1, and that's going to end up with 5/8. So the answer is D. All right? Or, of course, just use your intuition. Feel free to use your intuition for this question. This is kind of easy, this one. And question 9, super easy as well. I would say that it's a word problem with just some basic calculations. So I don't want to put it into any categories either. The approximate cost of restoring the Flying Scotsman was £4 million, whatever it is. And it says that it was about 500 times the cost of blah, 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 blah. So it is actually an engine. Well, fair enough. Basically, I just need to know what is 1 over 500 of 4 million. Which means that I am dividing 4 million by 500. So basically it has too many zeros, right? So you can pretend that you're just dividing 4,000 by 500 and then keep the other zeros. Which means that 4,000 divided by 500 is going to be 8. And then you still have 3 zeros left. You just need to copy it down. So the answer's going to be 8,000. Okay? As long as you are careful about the number of zeros, you shouldn't have make it wrong. Okay, and the next one, well, another question on fractions, but this time it belongs to the numbers and operations because there's not much of the words in it, right? Oh, operations. And it's on fractions. So now it says that adding 4 of the 5 fractions, a half, a third, a sixth, a ninth, and 1/18 gives a total of 1. Of course, you can try to put them together to make a 1. That's fine. Or the other way is just trying to add them all up. Because 4 of them is going to give a total of 1. So that if you take away 1 from the total of the 5 fractions, what's remaining is going to be the fraction that is not used, right? So essentially we just need to do a half, adding a third, adding a sixth, adding a ninth, adding 1/18. Take away 1. And you can see that all the denominators are fractions of 18, which means that you can easily try to find their common denominator 18. And the numerators are going to be 9, 6, 3, 2, and 1 respectively. All right, and then take away 1. So altogether, if you add these up, you're going to see that it's going to add up to 21, right? So we have 21 over 18 take away 1, which is 1 3/18. Take away 1. Of course, we can simplify 3/18 into a sixth. So the answer is going to be a sixth, which is C. All right? So that's how we know that which one of these fractions is not used. And then moving on to question 11. So, numbers and operations again. And this is basic operations, which is just a division. How many digits are there in the correct answer to the calculation? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, divided by 1, 2, 3. Well, this is going to be easy, because every 1, 2, 3 divided by 1, 2, 3 is 1, right? And then I just need to put the missing digits as zeros. So that's how it works. And you can count that it has got 10 digits. So the answer is 10. I believe you've all got this right. Have you? Okay, so I'm gonna hide myself for now because this is a pretty large question, so I can't put my head on the screen. So this is a geometry question on angles again. Essentially, you can see that if PR bisects the angle SPQ, it means that these two angles SPR and QPR are going to be the same, right? And also you can see that triangle PQR is isosceles, which means that the base angles are going to be the same, which means that PRQ is equal to RPQ. Now, 3 of the angles are the same in this question, and we're looking for the angle PQR. That's what we're looking for. Okay, so I'm going to put a question mark there. So, the other thing we know is that the ratio of angle SPR to PRS, which is that angle, is going to be 2 to 3. So I have pretty sufficient conditions already. First of all, we know that the angle SPR adding the angle PRS is equal to the remaining of the triangle SPR apart from the top angle, right? So we know that the interior angle sum of a triangle is 180 degrees. Take away 110 degrees. That's going to leave us with 70 degrees for the sum of these two angles. And we also know the ratio between these two angles, which means that you just need 2 parts out of 5 of the angle 70 degrees to find angle SPR. So it's 70 degrees times 2 parts out of 5. That's how you solve the ratio problems, right? And it's going to be 28 degrees, which means that it's equal to angle QPR and it's equal to angle PRQ, or like, oh, I was writing PRR. So probably that's just equal to angle QRP, and that's also equal to angle QPR. All right, these two angles, because we have said that these 3 angles are the same, right, in the very beginning. So we know that these 2 base angles are 28 degrees, which means that the top angle PQR is 180 degrees, which is the interior angle sum of triangles, removing the 2 28 degrees. And that's going to leave us with 124 degrees. So the answer is going to be A. Okay? That's it for this question. And as for question number 13, well, there are two ways to solve it. The first way is we can just look at it at the different views. So we can solve it as a 3 views problem. We know that this shape, no matter if you're looking at it from the left, from the right, or from the top, actually that's not precise, from the left, from the front, or from the top, basically that's the 3 sets of views, right? You're going to see a 2 by 2 square grid, which the dimensions are 6 centimeters and 6 centimeters. Because we know that the top and bottom are the same, the left and right are the same, the front and back are the same, so altogether we should have 6 views altogether, right? And then for each view, the area is 6 times 6, so that's 216 centimeters squared. That's the first way of solving it. And then the second way is, of course, you can see that all these 4 cubes are isolated from each other. So they would have all the surface areas exposed. So I have 4 cubes, each of them is having 6 faces, and each face is having an area of 3 times 3, which is also 216 square centimeters. All right, both way works, whichever you like. So that's for question number 13. And then question number 14 is kind of getting slightly harder. So this is basically the reason why this half paper is moderate, because this question is not extra easy. It belongs to algebra and is about the indeterminate equations. First of all, Billy has 3 times as many llamas as lambs. So let's say the number of lambs Billy has is B. So the llamas will be 3B, right? And Millie has twice as many lambs as llamas. So let's say Millie has M llamas, and the number of lambs is going to be 2M, right? So they have 17 animals in total, which means that altogether, that's going to be 3B adding B, adding 2M, adding M, which is 4B adding 3M, and that is 17. Okay, so this is our indeterminate equation. Now we can try to do the odd-even analysis there. Because we know that 4b, 4 multiplying an integer, the reason why b is an integer is because it is the number of lambs. Well, technically speaking, Billy will not have half a lamb, right? If they are keeping them as animals. So 4b has to be an even number, because 4 multiplying an integer has to be even, right? And 17, we know that it's an odd number. So what do I need to add to an even number to make an odd number? It means that 3m has to be an odd number. And because 3 is an odd number, if I want to make 3m an odd number, it means that m has to be an odd number as well, because the only possibility of having an odd number product is when you're multiplying 2 odd numbers together. So now we know that m is an odd number. Let's say I can try to start with m equals 1. If m equals 1, then it means that 3m equals 3, which means that 4b adding 3 is 17, 4b is 14. Which means that there's no integral solutions, because 14 is not a multiple of 4, right? And if m equals 3, then 3m will be 9, which means that 4b adding 9 is 17. So 4b is 8, which means b is 2. And that is a proper solution, right? And then when m is 5, of course you can see 3m will be 15, 4b will be 2, that's not possible. When m is 7, then 4b will be a negative number, right? So it means that this is the only set of solutions we have. M equals 3 and b equals 2. So now what is the question asking? It is asking us how many llamas are there. So the number of llamas will be m adding 3b, which is equal to 3 adding 3 times 2. And definitely that's going to be 9, right? So the answer is 9 for this question. And finally, the last question is, again, I know it might be some of your nightmares. This is the spatial recognition question. They just like to have these kinds of questions, don't they? So, it is saying that it is placing copies of the L shape shown on a 4x4 board such that the L shape covers exactly 3 cells of the board. Alright, I know that. And then she is allowed to turn around or turn over the shape. And the question is asking us what is the largest number of L shapes I can put on the board without overlaps. So, first of all, we know that it's a 4x4 board, which means that it's going to have 16 boxes, right? And each L shape is taking 3 boxes, which means that if I divide 16 by 3, I know that it's 5 with the remainder 1, which means that 5 is the maximum possibility. So we do not have to bother trying to put 6 L shapes into the grid because that's impossible. Now let's see if we can put 5 of these L shapes into the grid. So basically all you need to do is just a little bit of trying. We don't want to waste any space, right? Because we know that there is only 1 box remaining, which means that I would try to see if I can fit these edges to complete the length or the side lengths of the shape. We know that this is having a length of 2, this is having a length of 2, and the whole shape is having a length of 4. So let's say I am arranging 2 of them across the shape and do the same for the other 2 angles, for the other 2 vertices. So now I have 4 L shapes put in there, right? And in the middle I have 4 boxes. I can take any one of them. Like I can take any shape I like for the L. So that's how we can fit 5 L shapes on the board. Okay? So the answer is going to be 5 because I have found a way to put it in and I know that's the maximum possibility. Alright, so that's it for the first half of the 2018 paper. How do you feel about it? And if there's anything you don't understand, just let me know. I'll try to help that. Alright? So, see you next time, everyone. Bye-bye.